I'm just waiting. Okay, I can see myself, but I'm waiting for stream elements to show that I'm live, you know, just the usual. Okay, I can see it. There, I can see it. So today I'm just going to continue with learning SQL. I think I'm on, I don't know, what day am I? Let me check. Quickly check. What day am I? Videos. Oh, wait, no, you can't see it because it's not yet published. Day 2, day 3, day 6. Day 6. Okay, I'm on day 6. Designing databases and querying. Okay. So the last time was the first half of this, and then today I'm gonna do the second half of this. So yeah, I'm just gonna finish this and then end the stream. Later I might stream. I still need, after this stream, I still need to do my groceries. It's a Sunday. I don't need to do a lot of groceries, but yeah, mostly like for breakfast. Like my bread is running out, nuts running out. Maybe I'll buy some fruits. I don't know. Yeah, there's some stuff that is running out for next week, right? I have to do like a quick grocery, and then once I come back, I'm gonna stream again, but for a different one. It's for this another repo that I've been working on. I actually started a devlog on my Twitch. Like if you see like my latest, where is my latest? This one? Have you see? Yeah, this one. I started the devlog day 1. Yeah, I'm gonna continue on this. There's some stuff I did. Later I'm gonna, I guess, walk through what I've learned because I'm following another repo, like a starter for a Golang app, like a starter app, right? Like best practices and stuff. So I'm following how they structure the code, and then I'm like learning along the way, like learning line by line. And later I'm gonna explain, or not gonna explain, but more like I'm gonna walk through what I've learned, right? Because the last time I streamed, it was not like this. It was just one file, like main.go, and then I was trying to modularize it. But right now it's actually working. Like I've successfully modularized it. Yeah. And then loading the config here. Oh, no, here. Package. No, not internal config. The config, yeah, it's here. I'm gonna go through line by line how I did this, and then I'm gonna continue working on this. I still haven't done the logger, so I'm gonna work on this. It's still empty. So yeah. But first, before we start, I'm gonna apply some lip balm because my lips are dry. My lips are dry. Wait. Just waiting until I'm back. And the camera. That's weird, just like the shadow here. I think it's because of this first layer. Okay. Anyways, let's continue with day 2. I'm gonna finish this.
This idea we talked about last week, which was primary keys and foreign keys. This idea of trying to uniquely represent each item in our own table using primary keys, and trying to reference that primary key from some other table using foreign keys. So let's try to work on that now. And for this, we'll need this new idea called a table constraint. In SQLite, you can apply what's called a constraint to your entire table. A constraint means that some values have to be a certain way. Like, let's say,
Is that it? What? Oh. Oh.
for a primary that some values have to be a certain way. Like, let's say, for a primary keys must be unique. They can't repeat. And they must be, at least in our cases, going to be integers to be able to quickly like add on to them over time. Similarly, for foreign keys, well, a constraint is that if you have a foreign key, you better find that value in some other table. Otherwise, you violate this constraint to having a foreign key. So we have two kinds of table constraints, among others, but two of these are primary key and otherwise you violate this. You better find foreign keys or quickly like add, and they must primary key in our case is going to be integers to be able to quickly like add on to them over time. Similarly, for foreign keys, well, a constraint is that if you have a foreign key, you better find that value in some other table. Otherwise, you violated this constraint to having a foreign key. So we have two kinds of table constraints, among others, but two of these are primary key and foreign key. And we can apply these to our table by applying them underneath the columns we tend to say will be inside of our table. Let's try these two here now. So let me come back to my terminal here so we can implement our very own primary key and foreign key constraints. We'll go back to my SQLite terminal and clear my screen, and let's then pull up our schema.sql file so we can keep modifying our schema. I can now see I have the riders table, stations, and visits, and I have some columns that could be primary keys or foreign keys, but I need to declare them as such. So here in the riders table, what was our primary key? Well, it was ID. Every rider should have their own unique ID that should not be duplicated across any two riders. So to ensure that constraint is applied, I could follow this up with a comma and then say primary key ID, just like this. Now ID is the primary key of this rider's table. I can go down to stations and ask, what was my primary key? Well, similarly, it was ID, this ID column on line 8. So I'll type a comma, followed up with primary key ID, and now that ID column is a primary key. It has that constraint applied in stations. But now if I get down to visits, we'll have a few more options. Visits here actually doesn't have its own ID column that I created. I instead have a rider ID and a station ID column. So a few options here. One option is actually to make a joint primary key. I could have a primary key composed of two columns, both rider ID and station ID. If I applied that constraint, that would mean that if I were to ever insert a row that had the same rider ID and the same station ID as another row, I would trigger a constraint violation. Every row that has a rider ID and a station ID has to be unique in their combination of those two values. To write that kind of scenario, I could follow this up and I could say similarly, the primary key of this table is not just rider ID like this, but it's also station ID. Now this is a joint primary key constraint. But if we think about this logically, I mean, it kind of stands to reason that somebody would visit a station more than once. And I don't want to make sure that every combination of rider and station ID should be unique. I want people to be able to visit a station more than once. So maybe not the best design for this table, but I could certainly use it in other cases or other contexts. One other option would be to do what we did before, and to have maybe the ID column here of type integer, and then down below, make that our primary key, a bit like this. And now visits has its own ID column. But actually, SQLite, by default, will give me its very own primary key, one called row ID. It's implicit, I can't see it, but I actually could query it. I could query for row ID, all one word, and get back a unique primary key for this table. SQLite is automatically created for me. Now, we have seen the primary key options, but what are our foreign key options? Well, it seems like rider ID and station ID are the foreign keys of this table, where rider ID references the ID column in riders, and station ID references the ID column in stations. So to codify that, to make that a reality in our schema, I could follow this up with the foreign key. The foreign key of this table is rider ID, and it references the riders table and the ID column inside of it, using this syntax here. Now I could keep going. I could say I have more than one foreign key. I also have a foreign key called station ID, and that references, as we said before, the stations table and the ID column inside of it. So now here I have my completed schema. I have a primary key for the tables I've declared, an explicit column for a primary key, and now I also have foreign key D as a followed up with our schema.that constraint is a D. Do what we did before, and to have maybe point primary key. I could have a primary key composed of two columns, both rider ID and primary one rider ID of its own visit.
Wonder when you would use a joint primary key.
Visits, we'll have a few more options. ID column followed up with is like it doesn't have its own ID key. I could ID and station ID. If I applied that constraint, that would mean that if I were to ever insert a row that had the same rider ID and the same station ID as another row, I would trigger a constraint violation. Every row that has a rider ID and a station ID has to be unique in their combination of those two values. To write that ID has a constraint violation. Every row that has a rider ID and a station ID has to be unique. In their combination.
I wonder when would you use this? When to use joint primary key? Hmm. Interesting use. Many to many. It's interesting. Interesting. Mostly for
Of
many to
those two
many.
values. It's implicit. I can't see own primary key. One called default will give me, it's implicit, I can get back a unique primary key for this table. SQLite is automatically created for me. Now,
I think it's better to
we
be
have seen the
explicit.
primary key options, but what are our
I
foreign
like
key
the ID
options?
column.
Well, it seems like rider ID and station ID are the foreign keys of this table, where rider ID references the ID column in riders, and station ID references the ID column in stations. So to codify that, to make that a reality in our schema, I could follow this up with the foreign key of this table. So now here I have my completed schema. I have a primary key for the tables I've declared, an explicit column for a primary key, and now I also have foreign key constraints for those columns that should be foreign keys. So now let me ask, what questions do we have on the schema or on primary keys and foreign keys?
So yeah, I just noticed that whenever before we hadn't added the affinities and the keys, we were not applying commas after each column name. So what is the difference there?
Yeah, a good catch. So let me kind of show you what this looks like in my terminal so you can see it live. You, I think, had noticed that before we had, let's say, this primary key ID constraint in riders, we had done something like this. Let me just copy paste that. And we had removed this last column or comma from the name column. Is that right? And if that's the case, well, it's just convention, just style here. So if I want to keep adding some constraint or like a new line to my table, I should include a comma. Here, this name column was the last portion of my table I had specified. I have this column called name that has type affinity text, right? But now if I add this new constraint, we'll have to follow it up after a comma from this new column here. Notice now this constraint, primary key ID, is the last, let's say, attribute of my table I specified. I no longer need to include a comma at the end of it. So whatever is the last portion, I should not have a comma after, but everything else I should. Let's take one more question here too.
Would it be okay for the visits table to have an ID column as well?
Yeah, good question. Would it be okay for the visits table to have an ID column as well? It certainly would be. We could define our very own primary key for this table too. So let me go back and show you how that could work. I'll go to my visits table here, and I could try to add my own primary key to this table. I could say ID, make a new column here, make it of type affinity integer, like this. Let me scroll up. And now, let me add some new constraint. I could say, because I've made my very own primary key, I'll say primary key ID. Now, this table has a primary key that I've created called ID. And this will be in place of SQLites that it would have made called row ID itself, but hidden from my own view. Okay. Let's keep going then. We've seen table constraints, we've seen type affinities, but we could probably do more to improve the design of this table or this database. So let's introduce one more kind of constraint, this one called a column constraint. So whereas a table constraint applies to the table as a whole. A column constraint applies to a particular column. Column, let's say. Maybe I want a column to have certain data inside of it. Maybe I want to make sure it doesn't have null values and so on. I could do that with column constraints. There are 4 in SQLite: check,
I don't know what check is. Is it like if statement? Default is like if the value is null, you add a default value. That's, for example, let's say ID. Let's say name. Name, not if it's name string or text. Name text default empty string or something, right?
default not
Because if you don't put the default value, it will be null. If there's no value of name, it would be null instead of an empty string.
null and unique. And each one does something different.
Not null is that it cannot be empty. It's like required. Yeah. Unique, it has to be unique. It always has to be unique. I think when you add like the primary key constraint, ID becomes unique. That's like one of the things. It's like, yeah, primary keys must be unique. But like, let's say for example, like you want another column that is not a primary key, but you want it to be unique. Let's say like an email, right? Email address. So you add the email address, the unique constraint.
Check allows me to make my very own check, like check to be sure that this amount is greater than 0. Or I could use check to be sure something different, not null and unique. And each one does something different. Check allows me to make my very own check, like check to be sure that this amount is greater.
How do you do like multiple? I wonder how you do multiple comments in SQLite. I mean, in SQL, I think you cannot. Probably you cannot. Yeah, because I didn't know I use it, so probably not.
Than 0. Very own check. Like check to be sure that this amount is check allows.
It's like an if or like a validator or something. Yeah, but I haven't used check. This is all 4 check is like the one I haven't
allows me to
used.
make my very own check. Like check to be sure that this amount is greater than 0. Or I could use default. Default means if I don't supply a value.
I think the reason why I've never used check is because the check itself, the validation, is done both on the front end and the back end, like front end in JavaScript and then the back end in Python, right? Yeah, I think, yeah, but I could see the use of it. I could see the use of it.
Value. When I add a new row, it'll just use a default value. If I don't than 0. Or I could use default. Default means if I don't supply a value when I add a new row, it'll just use a default value instead. not null means I can't insert null or empty values into this column. In effect, it's required. Unique means I want to make sure that every row in this column is a unique value. It doesn't appear twice in my data set. So let's try applying a few of these to our schema here. Go back to my terminal, and now let me check out this. Well, I could try applying
Repos, courses. Okay, I added an alias because there was a problem where it still doesn't load the bash aliases on the first load of that. I don't know why. CS50 SQL. It's this, right?
applying the not null constraint when I know I want a column to be required effectively. Now, where could I best apply that? Maybe I could apply that to the name column in stations. Like stations must have a name. So I'll say the name column cannot be null. It cannot be empty in here. Line also should probably be not null. A station must be part of some line. I can't have an empty value for line, so I'll say
Okay, this is where I add this thing.
2, this should be not null. Now, I could apply this up at name. I could say writers must have a name too. Let me try that. I'll say text not null. Or I could leave it optional. I could say maybe text just on its own and let writers choose to supply a name or not. Now the question here is, should I apply not null to my primary key columns, like ID not null,
I think
or
you don't need
not null here? You might think that you should for thoroughness sake. Well, it turns out that when you apply the primary key
it's
table
not null and
constraint
unique
down
and
below
auto
here,
increment.
this already ensures that there are several constraints applied to this particular column called ID. Among them being that ID cannot be null. So no need to duplicate this and say that this ID cannot be null when I already have it specified down below that ID is a primary key. Let me check others here. You might also think, could I do it for rider ID and station ID? Should I include not null here? Rider ID, not null, station ID, not null. Well, that would be a good thought, but again, we're taken care of by our table constraint using our foreign key here. Again, this constraint will say, if rider ID doesn't already exist in the ID column of riders, I can't insert that value. And we could probably presume that if rider's ID is a primary key, well, null will not be part of this column, and therefore I already can't insert null for rider ID or station ID. This would be, in this case, redundant. So not null is good when you have columns that are neither primary keys nor foreign keys, and you want to make sure that they always have a value, that they're never null, effectively. Okay, so that is not null. And we could keep going here. We also had one called unique that makes sure every value, every row in this column is unique. Where could we apply this? I could try to apply it, let's say, to the name of a station. Like stations should have unique names. So I'll say not null and unique. Now this column has two constraints. The first, not null. It should always have a value. The second, unique. The value shouldn't repeat throughout this column. Line, I might leave without this constraint. I could imagine two stations being on the same line, like both on blue. I'll allow that in this case. Now again, we could try to apply unique to our primary keys or our foreign keys, as I just did here, but it's already taken care of for us using this primary key constraint. A primary key, again, is always going to be unique and never null. So we'll take advantage of that already using our primary key and foreign key constraints here. Okay, so we've seen unique and not null, and I might argue we're at the point where this schema seems to be fairly optimized, at least using our column constraints, our table constraints, our type affinities, and so on. So let's ask then, what questions do we have on not null and unique, if any?
So basically, to recap, if I understood correctly, it's not precisely about not null and unique, but about the concept of the key. Labeling a key immediately gives the attribute of not null, unique, and to be referenced, right?
That is true. So when you use a primary key or a foreign key constraint, there are other constraints that go along with that constraint. A primary key, for instance, must not be null. It must be unique, and so on. So it would be redundant to apply that again, to say that this primary key should be unique or not null. Good clarification there. Okay. So I think we're at the point where this schema is pretty well set for us, and we're going to need to think about, though, how we use this in the real world. Like if this is our schema here, we have riders and stations. Well, what could we do? I mean, riders tend to, they could register for the subway, and riders, well, they do visit stations. But I think if we applied this to the real world, we'd see that this isn't quite how it's actually done. Like riders don't really register that often. If a rider who's new to the city comes in, they want to ride the subway, they should be able to ride too. So it turns out, at least here in Boston, the MBTA doesn't really track riders per se, but they do track what we call Charlie cards. If you want to ride the subway, you get a Charlie card. A Charlie card allows you access to the subway, keeps track of your fare, your balance, and so on, and allows you to swipe in to certain stations. So and when we come back from a break here, we'll see how we can actually implement these Charlie cards instead of riders to make our system more efficient and more in line with what happens in the real world. We'll see you all in just a few. And we're back. So we saw last time this challenge of designing a system for the Massachusetts Bay Transportation Authority to represent riders and stations, people who get on a subway to go around Boston. But as we also saw, we learned that the MBTA doesn't keep track of riders themselves. They keep track of Charlie cards, this card that a rider might carry in their pocket. And they can scan this card at a station to enter, or even to exit in some cases, to make sure that their fare is counted as they enter that station. So let's think now how to improve our schema to represent not just riders like me, but Charlie cards themselves people might carry around when they enter the subway station. Well, we saw before, we had riders and cards, but our goal now is to remove riders from the picture, focus only on cards. Well, cards, as we've seen, might make a swipe at a station. If I enter Harvard Station, I might swipe my Charlie card to enter that station. And we could see that a card would have maybe many swipes involved. Like if I swipe at Harvard, I might also swipe at MIT or swipe at Park Street, and so on. We could see that a swipe can only happen at a single station at a time, though. Like if I swipe at Park Street, I'm only swiping at Park Street here. And similarly, a swipe might only involve one single card. So if we think about these entities and how they relate, we could also think about what kinds of columns we should have inside of each entity. In this case, I would argue we should have something a bit like this. We could say that a card has an ID for its primary key, in this case. Similarly, this card makes a swipe, and this swipe has itself an ID, as well as a type, some time that swipe happened, and an amount, or a transaction that is involved. So for example, let's say I swipe in at the Harvard Square station. That type of swipe might be to enter the station at some certain time. Now, associated with that swipe is also some amount in dollars that happened to be subtracted from my card. Like let's say the fare nowadays is $2.40. Well, that amount is subtracted from my card from this swipe. Now, of course, I do all of this at a station, which has our same columns from before, ID, name, and line. So a similar idea now, but we're replacing riders with cards and adding more information to these visits. They're instead swipes that could be maybe entering the station, exiting the station, or just adding funds to my balance, for instance. So let's see how we could improve our schema now using some new SQL keywords to alter our tables and add some new ones too. I'll go back to my computer, and let's see how we could try to alter the tables that we've already created. Like we already have a riders table, a visits table, and a stations table, but we could learn some new statements, some new queries to actually update and alter these tables as well. The first one, as we saw a little bit before, is this one called drop table. Arguably the most dramatic thing you can do to a table is just drop it, delete it like this. So let's try just deleting the riders table from our database. I'll go back to my database here. I'll type SQLite3 mbta.db to pull up this database again. And now if I type .schema, I'll see I have a riders, stations, and visits table. But no longer do I want to have the riders table. I want to remove that. So I'll say drop table riders, semicolon. Now I'll hit enter. No more riders table. If I and type go back to my database, this one called tables. We could learn some new riders table. We could try to new ones too. New could be already created. Like we already have a riders table, a visits table, and a state already created. Like we already have a riders table. We could try to all of queries to actually follow this database again. I want to remove the colon. Now I'll hit enter. No more riders table. If I type .schema, that's gone from my database. Well, what could I do now? I've dropped the table, but I'd still need to maybe update visits to instead be swipes. I could probably leave stations as is, but I want to update a table or alter its schema. I can use
How do you do it again? Oh, Control L. Okay. I don't know why the values. Why is this here? Stations, visits. There's no radars
some
anymore.
new commands as well. I'll use this one called alter table. Alter table looks a bit like this. I can use the alter table statement here and give it some table name, like some new command to visits to a new schema that's gone. No, I'll need to go back from our database. Delete it like this. So let's try to 3 mbta.db to pull up this database again. And now if I type .schema, I'll see I have a riders table. What could I visit to a table? Use this one. Alter its schema, leave stations as is. But I want to update a table or alter its schema. I can use some new commands as well. I'll use this one called alter table. Alter table looks a bit like this. I can use the alter table statement here and give it some table name. Like let's say alter table visits. And then inside this visits table, I get to ask, what do I want to do? Do I want to, let's say, rename the table? I could do that. I could also decide to add a column, rename a column, or drop a column altogether. Let's try first. Let's say rename the table. I could do that. I could also decide to add a column, rename a column, or drop a column altogether. Let's try first looking at rename to. I want to rename this visits table to a swipes table, representing not just a visit to the station, but a swipe of a car. So let's try this one here. I'll go back to my computer, and I'll go back to SQLite. And I'll say, I no longer want visits to be called visits. I ideally want visits to actually be called swipes. So let me try this. I'll say alter table, as we saw before, visits, rename to swipes, like this, semicolon. Now I'll hit enter. And now if I type .schema again, I see, oops, kind of strange, I'll type .schema again, I'll see swipes. No longer called visits, but now called swipes. Well, we saw I'd ideally like to add a type of the swipe. Maybe I'm entering the station, maybe I'm exiting, maybe I'm just adding funds or depositing some funds. So let me try adding, let's say, a new column to swipes. I'll say alter table, add column, alter table, swipes. I'm going to name that table swipes, like this. And then let's add a column called type. And this will have the type affinity text. I'll hit semicolon, enter, and now if I type .schema, I'll see, well, I have a column called TTP. I'll see, well,
Wonder why. Why is there a yeah, drop table fixes. It's okay. Add text.
I have a column called TTPE. So clearly I made a typo here. I had rider ID, station ID, this new column down below called TTPE. I kind of want to fix this, right? I don't want TTPE, I want type. So probably a good chance to use my rename column. I'll come back here and I'll try that. I'll instead do alter table, swipes, and I will rename a column now. I'll say rename the column TTPE to type, spelled correctly now. Hit semicolon, clear my terminal, type.schema, and now I see over here that type has been added to my table of swipes. I see rider ID, station ID, and now a new column called type. So through alter table, can we go ahead and add new columns, rename them even, or if I wanted to, just drop the column altogether. Let's say
Drop constraint. Yeah, there is a drop constraint. The problem is I don't know the foreign key name. This one. I don't know the foreign key. Hmm. Can I do like drop? Not sure if I can do this. Foreign key rider ID. Hmm. Hmm. Do I need to know the name of the key? Hmm. You need to know.
I add this
I
column
don't know how
type,
to know
and
the
I
name.
change my mind. I don't want it here anymore.
Yeah.
Go back to my computer, and I could try dropping a particular column. Let me try, in this case, alter
I'll just remove
table,
this.
swipes, and now let me drop column type, semicolon. Hit enter, and now if I type .schema, I'm back to where I began. So these are the commands we can use to alter our tables, to improve them if we make a mistake, during our first create table command, or if we want to add more functionality later down the line. So ideally, I could keep using alter table, add table, create table, drop table, and so on. But what I want to do here is just probably start from scratch. Like I have stations and swipes and so on. Why don't I just go back to my schema file and use that instead? So what I'll do is I'll drop table for stations, and oops, semicolon. I will drop table for swipes now, semicolon. I'll type .schema, and now I'll see nothing in here. I'll quit, and I'll type code schema.sql. Let me just start from scratch using this schema.sql. So we no longer want to have riders. We only want to have cards. So I could just rename this table here. I'll call it cards, create table cards. Now cards don't have a name. They only have some unique ID in this case. Now, I'll leave stations just as it is. This seems perfectly fine to me. Stations have an ID, a name, and a line with these constraints applied to the name and line columns. But now the visits table. Well, the visits table is no longer a visit to the station per se. It's more a swipe of the card at that station. So let's now say visits becomes swipes. And among these new columns to add are the following. I want to have not just an ID for each swipe, not just an ID for rider ID and station ID and so on, but also I want to have a type of swipe. Am I entering the station, exiting, or depositing some funds? So I'll say the type of this is going to be a new column, and the data type this holds will be text, enter, exit, or deposit for some funds. Now let me try another column too. I'll include a date time. A date time is like a timestamp. What time did this swipe actually happen? And I'll make this type numeric. Numeric can store all kinds of dates and times for me in this table. Now, let me add one final column. This one will be an amount. I'll also use numeric for this kind of column here. And I'll say that this column called amount can store, in this case, integers or real numbers like floats and so on. I'll probably decide on that when I actually add some data to this table. Okay, so here we've updated our schema to represent that diagram we saw before. I have cards, I have stations, and I have swipes that have some type associated with them, enter, exit, deposit, some date time, and some amount that was charged to me while I made this swipe. Either I added some funds, in which case amount is positive, or I subtracted some funds by entering or exiting, in this case, from the station. All right, so I have these tables now, and now I want to probably apply some of those same column constraints we saw before. Like here, it's fine, but I also want to make sure I'm not adding some data that I don't want to add to this table. So I could go back to my old friends, these column constraints. And we saw before, we had default and not null, unique, and check. We've used not null and unique, but we haven't used check or default. So let's start using more than just not null and unique, and also focus on check and default, and what they can do for us here. I'll go back to my schema. And let me just make sure that I'm making all the columns that I want to be required actually required. I'll go into my swipes table, and I'll say that type, this should be required. I should know whether I entered, exited, or deposited some funds. So I'll say text, not null. Similarly, for the timestamp, the time this swipe happened, I want that to be not null as well. I must know what time I swiped the card. And also, it makes sense for there to always be some amount associated with this swipe. Either I added some funds to my balance, or I removed some funds overall. So I'll make this not null as well. Well, let's see what we could do here with default. Default gives me some default value, some initial value to add to this column if I don't specify what kind of value to add. Well, this could be good for date time. Date time here is, again, the time stamp, the time I swiped this card to enter, let's say, Harvard Station. Well, if I want this to always have the current time, I could use default. I could say the
I don't know how to
default
do it in
value
SQLite.
for this column is this
U-
special
UTC
value here,
time?
current
Current
time
timestamp?
stamp in all caps. Current timestamp will show me the year, the month, the day, the hour, the minute, the second, all in one value, and insert that into my table. So as soon as I add a new row, if I don't supply a time for this date time column, I'll instead get back the current time exactly as it is represented in SQLite. Now, what could I do further than this? I could also try to add my very own check. Maybe I want to make sure that the amounts here are never equal to 0. Like, nobody should ever be able to make a $0 transaction or a $0 swipe. They're always being charged some money, or they're always depositing some money in this case. So I could say amount here has my very own check on this column. And inside check, I could actually write my very own expression to check for.
I wonder how.
I could say, for example, amount is not equal to 0. Using the
Interesting.
same operators we saw back in week 0, this will ensure that any value inside amount will not be equal to 0. Let's try it also for type. I mean, type can only have a few values. We saw enter, exit, deposit some funds. I could make sure that only those values are included inside my type column. I could say check that type is in some list of values. Going back to week 1 here, we talked about in. I could say maybe the type is in enter, exit, or is in deposit. So now, when I have this table called swipes, I'm representing what I'm actually doing when I go to Harvard Station. I have here a visit from myself, my very own ID here, which I'll update in a second. I have a station ID where I'm actually going to visit. I have a type that I'm going to use to enter, exit, or deposit some funds at this station. I'm doing it at a certain time, and I have an amount
Keep on forgetting
associated
that
with this
a
transaction.
raw string is
Now there's
single
one
quote.
thing to fix here, which is that we're still talking about riders inside our swipes table. So let's fix that here too. I'll go back to my computer, and let's try fixing this. I have a rider ID inside of my swipes table, but no longer do I have riders, I have cards. So let me say that this is now a card ID, and down below in my foreign key, I'll say that this card ID column references the ID column in cards. And I think this should represent everything I want to represent about swipes at the station. So let me ask now what questions we have about this new schema and the constraints we've applied.
I wonder how could you delete or drop a table riders when you use ID as a foreign key? I tried to do that, but I got an error.
Yeah, so you're getting into some more advanced stuff here. And suffice to say, for now, my foreign key constraints aren't actually being checked right now, but yours might be. If you try to drop a table that has some data that's referenced by a foreign key, SQLite will warn you, perhaps just tell you, you can't do that because this ID is referenced from this table over there. So in that case, best to delete the value that has that foreign key and then proceed with dropping that table altogether. Good question there. Yeah. Let's take one more.
How much the syntax same the other SQL languages, same as SQL SQL languages? How much the syntax same?
Yeah, good question. So here we're using the SQLite database
DBMS.
management system. It is similar to, but distinct in some ways from others like MySQL or PostgreSQL. I would say that most of what you're doing here could also be ported to MySQL and PostgreSQL, with a few exceptions that you might need to treat on a case-by-case basis. In fact, the developers of SQLite built things so that it would be easy to port their database schemas to another schema like MySQL or PostgreSQL as well. But good question there. All right, let's take one more question here.
Imagine if we put in the ID, we don't put any data type, it's going to give us, in the schema, it's going to give us a text or...
Yeah, great question. So you're asking if I didn't tell SQLite what kind of type affinity a column had, what type of affinity would it actually have? A great question.
It doesn't?
In this case, by default,
Numeric?
SQLite gives the numeric type affinity.
Interesting.
Where numeric can store integers or real values. But if you give it like a string of text, like let's say redline, it will store that for you too, kind of non-intuitively, but it will. But the default type affinity is numeric in this case if you don't otherwise specify. Good question. Okay, let's come back then, and let's focus on wrapping up on a final few pieces here. So we've seen some table constraints, which we applied primary keys and foreign keys. We saw column constraints, where we could make sure that certain values were given to us through not null. We could also make sure that let's say the value is in some list of values using check, or making sure that it's not some value, also using check as well. Default allows us to specify a given value for every new insertion of rows here. And this is actually pretty important to have, not just schemas that have column names and let's say type affinities as well, but also constraints to make sure the data we insert works well for us. And there's actually a story behind this person who's on the Charlie card. This person who's on the subway, his name is Charlie, and he's perhaps the most famous subway rider in all of Boston. Back in the mid-1900s, the band called the Kingston Trio wrote a song about this man named Charlie. Charlie supposedly got on at the Kendall Square station where MIT is, and he made for Jamaica Plain. But once he got to Jamaica Plain, they got to ask him for one more nickel, and well, he didn't have that nickel, so he got stuck on the train for years and years and years and couldn't get off of the subway. So keep in mind, Charlie, when you're writing your own database constraints, making sure that if you get on the train, you're able to get off of it at some point, right? Don't end up like Charlie in this case. So with this in mind, you're able to design your very own database schemas that keep not just certain columns involved, but also type affinities.
That story is true.
Types that those data types, types that the columns can store.
The Charlie.
You're also able to apply constraints to those columns to make
There's
sure
always
that the
the
data you're
somewhere.
inserting
Yeah, why would
is
I
data you actually want to have
let them
in
off?
that column.
It's just one
Next time,
nickel.
we'll focus on actually adding data to our columns to actually write data to a database file, to insert, update, and delete that data altogether. So with that in mind, we'll see you
Okay,
next
writing.
time.
Next stream, not the next stream, because later I'm gonna work on the Go farm. Maybe, I'm not sure. I'm not gonna make promises because I always break it, especially on streams. Whenever I say I'm gonna stream on this day, I some things happen, or I procrastinate and I don't do it. But yeah, next stream on this specific stream, okay, on the Learning SQL, I'm gonna do the thing. I'm gonna answer the things here. Okay, back terms. Just spammers. We have that all the time. Where is it? No, it's in SQL. CS50, CS50 SQL. There, problem set 2. So next time I'm gonna work on this. ATL, happy to connect. History. Yeah. This is a quick stream. I just wanted to finish this because the last time I streamed was like, wasn't Friday, I think, but that was for another stream. But like the last time I streamed this series was like a week ago. Yeah, it's hard to find time when you're working. Okay. Yeah, but I'm trying. Okay, I'm trying out a new schedule. I'm trying out a new schedule. I mean, for my work. I mean, not for the streams, but yeah. And then I'm trying to like fit the rest of my stuff because again, I'm living alone. So I have to make time for chores. I have to make time for other hobbies, not streaming. That doesn't involve streaming, right? Like reading manga, or I don't know, watching YouTube. I watch a lot of YouTube. I really like psychology. Like I like learning about it. I like reading stuff about it. I like watching stuff about it. I really like psychology. I'm focusing more on like how to be emotionally happy, how to be fulfilled, right? Being alone, being single. Yeah, because how do I say it? Because people have done it before, right? There's like musicians out there, or like, or people pursuing a creative track, and they don't have partners, but they're happy, they're fulfilled, and I'm like, they're yeah, because the easiest way to be fulfilled, to feel fulfilled, is to find a partner, find someone, right? Find someone, have a relationship. It's like the easiest, right? Because there's feedback and stuff. But like, but people have done it before, where they can be happy, they can be fulfilled without a partner, and that's what I'm trying to learn. Yeah. So part of it is like getting a pet, but right now I can't afford it. I mean, I'm. It's not that I can't afford it. It's more like I'm living a life where I'm living comfortably, single, and I have savings, no debts, by the way. I have savings, but I feel like if I have a pet, it's gonna be expensive. Yeah, it's gonna be expensive, and I have to rethink how I spend my stuff, because I don't want to sacrifice my savings for a pet, if you get what I mean. Like, because I like saving. Like right now, I'm focusing on like emergency funds, because I just started my career. It's barely a year. I mean, it's more than a year now. I mean, it's November. It's past October. October last year was when I was hired in my current company. So yeah, it's a year now. But I want to focus on like just emergency funds first, and then once I accomplish it, like the 6 months emergency fund, I'm gonna start investing. But yeah, for now, like my immediate goal is 6 months emergency fund. So yeah, that's why I'm like, where does the pet fit in that equation? If you get what I mean. Yeah, because yeah, I don't know how much having a pet costs, but I have to imagine it's expensive, right? Because there's like vet, there's like grooming, there's what else? You have to walk them. You have to buy a lot of stuff like food, water, and then you have to buy toys. I don't know, like average cost of owning a pet. Average cost, average monthly cost of owning a pet. Philippines in pesos. Really? 5,000. I 1,000 is like $20, by the way. That's too little. $20 is too little. And then 5,000 is like $100 monthly. I don't think, like, for example, if you US, how about US? See, like it's like $100. Like I was like, nah, no way, no way. In the US, it's like 1,000. This makes more sense, at least for me. Carrying a dog. Annual, this is annual. 80 to 440. Okay, so realistically, it's like, never mind, it's like annual. Realistically, it's like around this, 80 to 440. Okay, $5,000 makes sense. I mean, 5,000 pesos makes sense, like, which is like $100. But I think I want to spend more for my pet. Because the way I see pets, they're like family. That's how I see them. So I wanna pamper them with love, okay? I want them to be healthy, so I want them to exercise, I want them to move around. So I also have to factor in like gas, because here, at least where I live, there's no parks here, pretty much. Like, I mean, there are, but like, it's a disappointment to call it a park. There's barely any trees. I mean, there's like a park somewhere, but I have to travel with my motorcycle there. So I can't really, I'm not sure if I can do that every day. I mean, I can, but I have to buy the bags, like this one, the pet bags, because I don't have a car. I don't have a car, so I have to put them here. Not a pet bag, like for motorcycle, because I'm motorcycling. Pet carrier for motorcycle. Puppy. But what if it's a dog? So I can't buy a big dog. It has to be a small dog. So I can carry them around. Yeah. Mm. Yeah, there's a park quite. It's not that near, but it's like here, MacArthur Park, where I live, like near where I live. Well, yeah, this park. I think this makes sense because it's big. Yeah, it's like this is grass, and then there's this roads. This is like the seawall. Yeah, it's good to jog here in the morning, like when there's no sun. I wonder if there's like photos, like street view. Is that like a street view? Yeah, this this is outdated because I know it's done. Construction is done already. Yeah. Something like here, right? But more on the grassy areas. This is more for humans. I'm not sure if you can even bring pets here. The problem I have with the Philippines is that there's like very little establishments that, you know, that allows pets in. I only know one. There's the park. Yeah. And then there's like the sea right there. I can bring the dog here and walk them here. I only know one place where I can actually bring my pet. Ibarra maps. Tacloban. This area. Ibarra Lounge. This is the only one I know. Because I asked them when I went there and visited Red. Why can't what? Ibarra Lounge. Mm, there. See, they're good with pets. Yeah, it's small, but I like it there because usually I go there when there's no people. I mean, I'm very introverted. I like being alone a lot. Yeah, this is the only place I know, and it's just one. It's just one. I'm not sure if there's anything else. Yeah. But yeah, it's like there's like the cost of owning a pet, right? And then you have to also consider the environment where they're in. That's why I'm like debating should I really want to get a pet, but at the same time I'm like, is it practical to get a pet here where I live in Tacloban? Like is it practical? Yeah, that is the thing that I'm still debating. But I really want a pet. I really wanna learn how to take care of it, how to take care yeah, I have to take care of someone else that's not me. Because right now I've been living alone for like how many months now? I started in March, April, May, June. I started March. Oh, 8, 1, 2, 3, 4, 5, 6, 7, 8. About 8 months now, right? I've been living alone for like about 8 months now. So I'm like, wouldn't it be great to have a companion? Yeah, maybe like a pet cat or a pet dog. I don't really care. But like right now, I'm leaning towards a dog, even though I'm a cat person myself. But I'm leaning towards a dog because a dog, as much as I like cats, okay, I think I'll get a cat sometime in the future because I'm a cat person. But as much as I love cats, I feel like a dog makes more sense because it will force me to go out. Because I'm the type that I never go out unless I have a reason to. Like, for example, after this stream, the only reason that I'll go out is because I need to do my groceries that have some stuff that is running out. Well, yeah. Yeah, like either going out for groceries or hanging out with people. But like by default, I don't really go out. Yeah. But yeah, that's about it for me. I'm done with the thing. Finally, I'm done. I mean, I've done half of it already before. Next is the thing, the problem sets, and then yeah, I'm done with week 2, and then I'm on week 3. Next. Hopefully, I can finish it on the next stream. All the problem sets for this. So yeah, that's about it for me. Thank you guys for watching. Bye bye. Stop streaming.